In this video, we will practice graphing the tangent function with changes in period, midline, and phase shift. But first, let's take a look at the parent function so we can get a feel for what that looks like. So I'm putting 4 marks on the x-axis because each mark represents a quarter of the period. The main thing that you need to understand is that the tangent function begins and ends on the midline with an asymptote, a vertical asymptote, right at the middle. So that much you need to memorize. The tangent function begins and ends on the midline with a vertical asymptote right down the middle. Also, the parent function is always increasing from left to right. So if I go 1/4 period over, I'm going to have another point at the amplitude. For the parent function, that will be 1. But whatever the amplitude is, there will be a point here. And the graph will be increasing as you approach that asymptote. And then beyond the asymptote, the graph is going to jump down here. Okay, so 1/4 period after the asymptote, the graph will be right here. So the graph should be increasing as it approaches the end of its period. So this is what 1 period of the tangent function looks like if we're analyzing the parent function. Now in general, we will graph 2 periods of the tangent function because the period of the tangent function is only pi, whereas sine and cosine, the period is usually 2 pi. The period of the tangent function is only pi. That will change if there is a b value. Okay, the b value goes right here. But if there's no b value, the period will be pi. If we do have a b value, the period will be pi divided by b. So don't get that confused from sine and cosine, which were always 2 pi over b. For tangent, it'll just be pi over b. Okay. There is no amplitude for the tangent function. Glancing again at the parent function, notice that the tangent function goes up forever and down forever. So that number that we normally associate with amplitude will give us a critical point, but it is not actually the amplitude. So that's why we are not listing out what the amplitude is. That -7 will still play a role in the graph. Let's talk about the equation of the midline. I can see that there is no vertical shift. There's no number being added onto the end. That means that the midline will be y equals 0. It'll be the x-axis. Okay, I can see there is no phase shift for this first problem because you get a phase shift when you have like x minus pi over 2 in parentheses, something like that. So nothing is being added or subtracted directly to the x value, so there is no phase shift. So let's go ahead and start doing this graph. Okay, so here is my x-axis. Since there is no phase shift, we are going to start the graph right at 0. I'm going to go ahead and put the y-axis right in the middle since we are going to do 2 periods of this function. So I'm going to put 4 marks to the right, 1, 2, 3, 4, and I will put 4 marks to the left. Okay, each one of these marks represents a quarter of the period. So since the period is pi, that means a quarter period will be pi over 4. So this will be pi over 4. And then the next one over will be 2 pi over 4. But 2 pi over 4 simplifies to pi over 2. And then the next one will be 3 pi over 4. And then the last one would be 4 pi over 4. But of course that simplifies to simply pi. And to the left, we will of course have negative pi over 4, negative pi over 2, negative 3 pi over 2, and negative pi. So we have now labeled the x-axis. What about the y-axis? So the number that we normally associate with amplitude will not give us amplitude, but it is still a critical number. So that's why I'm going to put a 7 here and here, because that number will still tell us a critical point when we do the graph, even though it's not called the amplitude. So we are ready to begin the graph. Remember, as I told you a moment ago, the tangent function begins and ends at the midline. And then there will be a vertical asymptote right down the middle. So we're going to have a vertical asymptote right here at pi over 2. The tangent function is normally always increasing, except notice that we have a negative 7. That negative sign is going to be a reflection over the midline. So the graph is upside down, so instead of being increasing, this graph will be decreasing. 1/4 period over, we will be down at negative 7, and that's why this negative 7 is important. Okay, so on the other side of the vertical asymptote, again, the graph has to be decreasing. That means we will expect a point right here at positive 7, so that from left to right, the graph will be decreasing. So let's go ahead and draw this portion of the graph. Again, the graph has to be decreasing as it approaches the asymptote, so it's going to look something like this. And then on the other side, again, it has to be decreasing, so it will be something like this. Okay, so here is 1 period of the tangent function. Let's repeat that same effect on the left-hand side. I think I'll change colors just so you can clearly see the 2 separate periods. The tangent function begins and ends on the midline with an asymptote right at the middle. All right, normally the tangent function is increasing, but because it is upside down, it will be decreasing. So I'm going to have a point here at negative 7. So here I am decreasing. And then at this 1/4 period, I will have a point at positive 7 so that the function will be decreasing. So this is what 2 periods of the tangent function will look like. Finally, we need to talk about the equations of the vertical asymptote. So vertical lines are always x equals a number. So I'm going to start off with x equals. I normally like to pick my first positive asymptote if there is one. So we have a positive asymptote here at pi over 2. So x equals pi over 2 is the equation of this vertical asymptote over here on the right. But the tangent function is a periodic function. It repeats this same pattern over and over again in both directions forever. So the question is, how far apart are these asymptotes? Well, I'm going to have one asymptote per period. So see, I have one asymptote for the green period, I have one asymptote for the red period, and if I continue this pattern, there would be one asymptote for every period of this function. So how long is the period? So looking back, the period is pi. So there will always be a connection between the equation of our asymptote and the period, because if I add the period, if I add pi, that will give me another asymptote. So if I were to take pi over 2 and add pi to it, that would give me another asymptote. And if I added pi again, that would give me another asymptote. So because every multiple of pi, every multiple of the period will give me another asymptote, I'm going to add a letter to the end of this and say pi n. N represents any integer. So this equation captures all of the vertical asymptotes. I'm starting with one known asymptote, and now I'm adding a multiple of the period, pi n. And n can be a negative number as well. So if n is -1, for example, that's where this asymptote right here would come from. So having this n here will give me all of the vertical asymptotes for the periodic function. Just to be extra clear, this number that we're adding with a multiple, this is always going to be the period. So these numbers will always match. If this had been pi over 2, then I would have pi over 2n. For problem number 2, the period is unchanged because the b value, which you can't see, is a 1. So that means that the period is still going to be pi, just like the parent function. The midline, I should say that's the b value. The midline is affected by any number that is being added or subtracted on the end here. But there is no such number. So the midline will still be the x-axis, which is y equals 0. We will come back to vertical asymptotes later. The phase shift is going to come from this h value, but it's going to be the opposite of what you see here. So if you see plus pi over 3, then the phase shift is actually negative pi over 3. So that is very, very important because you always want to start your graph at the phase shift. So here comes my number line, but I'm going to start my graph at negative pi over 3. And then I will put 4 equally spaced marks. 1, 2, 3, 4. Each one representing a quarter of the period. Now I need to label these values with a quarter of the period. Since the period is pi, that tells me that a quarter period, which is the period divided by 4, so pi over 4. So to get the next value on the number line, I should be able to take my phase shift and add pi over 4. I'm adding a quarter of the period. However, I need like denominators. So I'm going to have to rewrite both of these as multiples of 12. So you can imagine I'm going to multiply by 3 over 3 right here, and I will multiply by 4 over 4 right here. So what I have is negative 4 pi over 12 plus 3 pi over 12. And that is going to give me negative 1 pi over 12. So that is the next value on the number line, negative pi over 12. I almost forgot the 1. Well, I need to keep going and find the next 3 values. So I'm going to add another quarter period. And I might as well stick with this form since I already have like denominators. So I'm going to add another 3 pi over 12. That's going to give me 2 pi over 12, which reduces down to pi over 6. So the next value will be pi over 6. All right, I keep going. Let's add another 3 pi over 12. So that will give me 5 pi over 12. Okay, so now I have 5 pi over 12. Okay, I need one more value, so I'm going to add another 3 pi over 12. So that is going to give me 8 pi over 12. Let's see, so both of these are divisible by 4. So this reduces down to 2 pi over 3. So I will have 2 pi over 3 for that value right there. Okay. Now, so let's go ahead and graph this part of the function. We are going to need the y-axis in the mix. I see we have a negative pi over 12 and then a positive pi over 6. So the y-axis is at 0. So it's definitely going to be in between these two values. So, okay, that's about to be very crooked. So make sure that you have your y-axis in between these two numbers. And though there's no such thing as amplitude for a tangent function, we still need these two marks, and we need to label them. And this a value, although it is no longer the amplitude, it still is going to be important as we do the graph. So we still need to label this as 2, and it's hard to see, but I'm going to squeeze in a negative 2. So the tangent function begins and ends on the midline. And remember, the midline is the x-axis, y equals 0. So the tangent function begins and ends on the midline. And we're going to have this vertical asymptote right down the middle. The parent function for tangent is always increasing unless there's some kind of a reflection, which there is not. So this will be increasing. 1/4 of a period over, the next point is going to be at the a value. So notice the a value is 2. So I'm putting a point at a y value of 2. So as I said, the tangent function will be increasing as it approaches the asymptote like this. On the other side of the asymptote, this next point, a quarter period later, will be down by the amount of the a value. So I hate to put a dot right in the middle of this number, but that's where it belongs, the a value down. So you can see that the tangent function is increasing as it goes away from this asymptote, approaching the end of the period. So this is what one period of the tangent function looks like. We are supposed to graph 2 periods, so we are going to graph sort of the image of this, another period to the left of negative pi over 3. To find those values, we are going to have to subtract the quarter period. So I'm going to take my negative pi over 3, and I am going to subtract the quarter period. I'm going to subtract pi over 4. So remember, when we make like denominators by having 3 over 3 and 4 over 4 like this, we discover that these are the same as having negative 4 pi over 12 and minus 3 pi over 12. Okay, so let's just stick with this. And if you do that subtraction, you are going to get negative 7 pi over 12. We are subtracting because we are finding the values going to the left. So let's count our 4 spaces. 1, 2, 3, 4. So our next quarter period over is at negative 7 pi over 12. If we subtract another 3 pi over 12, all right, let's subtract another quarter period.
that's going to give us negative 10 pi over 12. But that reduces down to negative 5 pi over 6. So the next value will be negative 5 pi over 6. Okay, great. Let's subtract another 3 pi over 12. Well, that's going to give me negative 13 pi over 12. So I've got negative 13 pi over 12. And finally, I need to subtract one more quarter period. And that's going to make negative 16 pi over 12. Both of these are divisible by 4, you guys. So if we divide these by 4, that's going to make negative 4 pi over 3. So I'll just squeeze this in over here. Negative 4 pi over 3. So these are the values we will use to make the left period of this graph. Remember that the tangent function begins and ends on the midline, and there will be a vertical asymptote right down the middle. This is in my way. There will be a vertical asymptote right down the middle. The tangent function is always increasing, so I'm going to need a point right here at the a value, and the function will increase as it approaches the asymptote. On the other side of the asymptote, 1/4 of a period later, there will be a point right here below the midline, the amount of the a value. And the function increases as it goes away from the asymptote and approaches the end of its period. So this is what 2 periods of the tangent function will look like. So before we go, we need to talk about the equation of the vertical asymptotes. So we have 2 vertical asymptotes shown. Let's pick the positive one to begin with. It really doesn't matter which one you pick to start with, but I always like to pick the positive one. Any vertical line has the equation x equals something. So this is x equals pi over 6. Okay? Now, we are going to have one asymptote per period. So we need to add multiples of the period. So for this particular problem, the period is pi. So that pi is going to show up right here every single time. And I'm going to put an n on it to represent all of the periods. All right? If n is 2, that means that there will be another asymptote if you add 2 pi. If n is negative 3, that means you'll have another asymptote at negative 3 pi. Please understand that if the period were, let's say, pi over 3, then this part of the asymptote equation would be pi over 3n.